So y equals 3x plus 7 divided by 4. And this is your inverse function here. Now the next part of the problem says, is the inverse relation a function? Why or why not? I don't really remember what we said last time, but this is a function. It definitely passes the vertical line test. It's some sort of a line like that. You can maybe say that passes vertical line test, VLT for vertical line test.
So it does pass the vertical line test?
Yes, yes. So function, yes. Again, that vertical line test means any vertical line you draw only hits the graph one time. All right, any follow-up from that or move on to number 5?
We can move on.
Okay. All right, number 5 here. We have another function. It says find the inverse of the following algebraically. That's what we've been doing. There are ways to do it graphically, but this one is a problem. Now, one of the things I should point out here, and the way this is written is this actually does not have an inverse in the traditional sense. I guess I should look up in your notes and see if they actually address this. The reason it does not have an inverse is because it does not pass the the horizontal line test. A horizontal line hits this 2 times. And so when a horizontal line hits the original function 2 times, it does not have an inverse. But, having said all that, like, we can still do the inverse. It's just that there's no domain restriction. So I'm not really sure what to say here. Basically, look here. Okay, I see what they're doing. All right. Yes. So let's just proceed here. I can see what they want you to do in this problem. Y equals x squared minus 7. And then we're going to switch x and y, just like before. So no change there. Next, we'll add 7 to both sides. Okay. And this is I'm just going to swap positions. I'm going to put y squared on the left, x plus 7 on the right. Hopefully that's okay. When we take a square root of both sides now, the square root always goes with a plus or a minus. So this is saying y equals plus or minus the square root of x plus 7. And graphically, the positive square, this is y equals positive square root of x plus 7. This is y equals negative square root x plus 7. And this is not a function. So even though it has an inverse, it's not a function because the vertical line hits it 2 times.
So I would write it's not a function because the vertical line
Yes.
hits the graph twice.
Yes, not a function. Yes, vertical line hits 2 times.
All right.
Okay, so the mistake, I think, is to think that, oh, well, it doesn't, that means none of them are going to have an inverse. No, just this one. The others should work out nicely. All right, so this one here, just a little rewrite here. Y equals x plus 3 divided by x. Now you can actually do the following here, which I think would make this a little bit easier, is you can divide both of these by x. And then this becomes x over x becomes 1 plus 3 over x. Okay, just a little bit of manipulation to start. I don't see why you couldn't do that. But the next step here is to switch x and y. So y becomes x becomes y. X equals 1 plus 3 over y. And we're going to now solve for y. Okay, so to do that, we're going to subtract 1 from both sides. So, and I'm going to just flip positions again. So it's actually, I don't need to do that quite yet. Let's do it. X minus 1 equals 3 over y. Do you remember how to get a variable out of the denominator?
Don't you have to? I think so. I keep like you have to flip the fraction like to make it y over 3.
You can actually make it y over 3 equals 1 over x minus 1. Yeah, that actually does work. Glad to hear that. That's a more advanced way of doing it. You can clear the 3 out here on the bottom by multiplying both sides by 3. And that leaves you with 3 over x minus 1. To determine whether it's a function, it looks like they're graphing it. So, go to your Desmos if you want. Here, I'll graph it for you. But you want to graph the new function here. I'm going to snip this in. We take a look at it. You're going to see that it does pass the vertical line test. So let's do that. Make it a lot smaller. Okay, so this does in fact pass the vertical line test. So the inverse here is a function.
Okay, I'm ready for number 7.
Okay. All right, let me get back to that. It was on another screen. All right, it's number 7 here. All right, so square root didn't quite make it in the problem there, but you can see f of x equals square root of 2x minus 1. Start by writing y instead of f of x, and then switching x and y. First question for you of the day here. How do you undo the square root? How do you undo the square root here?
You have to square like
Yes, you square both sides. So on the left, it's x squared. On the right, it undoes the square root. Okay, so would you try solving for y from here? Basically 2 steps to get to that point. Give that a try and let me know what you come up with.
you want me to do what again?
Say that again.
You want me to get y by itself, right?
Yes, just like in all the previous problems, you got to undo whatever's on the side with y. So your focus is on everything over here to the right.
So when I got it by itself, I got x squared plus 1 over 2 equals y.
All over like that, x squared plus 1 over 2.
Yeah.
Okay. Can you go to Desmos and graph this for us? And what I would like you to do, just as a reminder here, you do have to type in the y. Like if you go back up and look at our previous one, you have to type in the y. You want to do the fraction bar first after after the equal sign, because then it'll give you space in the top and the bottom.
Got it. What is the fraction thing? Oh, I'm using the little keyboard.
Just the, it's the slash. So the fraction is slash like that,
Okay.
or you can look for the division operator in the keyboard.
Mhm. Give it a little big smiley face. That's
So
one.
it should be sort of something that opens up like this, a
Yep.
little bit above. Good. And that does pass the vertical line test. So we're good.
So it is a
This,
function.
it is a function. Yes, it's a function. All right, new problem here, number C. It says it asks you to determine whether the functions are inverses of one another. All right, so let's take a look here. On the left here, how do we want to do this? Minus 1/5 x plus 3/5. So one option is to actually find the inverse of this or the inverse of this and show that they're the same. Let me look quickly and see what your textbook does. The other option is you actually have to find the composition of both, which is apparently what they want you to do. Darn. Okay. All right. Well, that's what we got to do. So the way that they want you to do this is through composition. They first want you to take this right here and put it in for x. You take the inside function and replace it in the other function. Minus 1/5 times parentheses minus 5x plus 3 plus 3/5. And then you have to simplify this. Okay, so to do that, we will distribute the negative 1/5 to both terms inside here. And it looks worse than it really is. They are fractions, but it's okay. It will kind of work out nice. So we have negative 1/5 times negative 5x. That's just x. Negative 1/5 times 3 is minus 3/5. And then add 3/5 here. That's just bringing it down. What do you notice about the two fractions?
They're the same except the 1/3 is negative and 1/3 is positive.
Yes. So this is good. This is really good. What we want is we want the composition to equal x. So we've gotten half of it. We feel real good about that. But then we have to go the other direction now. And going the other direction means finding the composition the other way. So let me just do a couple of snips here again to get this. So we're going g of f of x now. G of f of x now. So this time we're taking f of x right here, and we're putting that in for this x there. So in the previous problem, we went the other direction. We took all this, put it in for that x. Now we're going the other way. And again, it probably looks worse than it really is. Negative 5 times negative 1/5 x plus 3/5 plus 3 like that. And then just like the previous problem, we're going to distribute in. So this becomes 5x minus 3. I'm sorry, not 5x. They cancel. Negative 5 times negative 1/5 is 1x. Negative 5 times 3/5 ends up being just negative 3 plus 3. And again, those cancel and you're left with just x. Okay, so you can say, yes, these are inverses. And it's because the composition produces just x.
All right.
All right, so number 9 is exactly the same thing. We'll do it exactly the same way. So f of g of x is the first thing. And that means to take this function right here and put it in for x. So you have x minus 1/2. That's taking the place of x. And then you're adding 1/2 to it. and that equals X.
Right.
Okay, so that's good. We're feeling good about that. But now we've got to go the other direction, G of f of X. And that means to take this one and put it in for X. All right, so, all right, we'll see. So that is X plus 1/2 minus 1/2, which does also equal X.
So that's also, so yes.
Yes, yes. Now, does this always work? No, it does not always work, but it's good to do problems that do work so you can see the process. But no, it would be a mistake to think that you can always do it this way. And it works. All right, so I'm going to go back and look at example 9 because I don't know why they want you to do it a certain way. When it says like, do it the way that's in example 9, they're saying like, you better do it this way or we're not going to give you credit. So
Yeah.
let's take a look here. All right, I see what they're doing here. So the cost of this birthday party is $500. So Dwight will be celebrating his 7th birthday with a swimming party that his parents are planning for him. The facility rents for $500 plus $25 per guest, including lunch and drinks. Okay, so you have to write an equation for that. The cost, C, is 500 plus 25 G. Every guest costs you $25. So they better bring a birthday present equal to the $25. Is that kind of the rule?
I would assume so.
Yeah.
I would assume so because that's how my mom does it. She's like, okay, they have to bring a gift with equal amount because, you know,
Yeah. I mean, it only makes sense, you know.
like if you that $500 can like bring a few people to Disneyland. I will say that.
Yeah, no, I mean, smaller is better sometimes.
That's my birthday went to Disneyland.
I like it. Did you do the both passes or did just do it at Disneyland?
No, I did both because I'm a nerd.
That's awesome.
Yeah.
Cool. Did you see have you been to Star Wars? What's it
Now,
called?
because when COVID started, I couldn't go.
Okay. Hopefully you can get back. I heard it's pretty good.
I haven't been to like Disneyland in 3 years, but I saw it at Disney World, so it was cool.
Cool. All right. So the way they have you do this in example 9 is you have to find the inverse. Now, a lot of students don't like using different variables. What you can do here is rewrite it as X and Y and then find the inverse the traditional way. You just have to remember to switch them back at the end. Or you can say, hey, Matthew, I'm comfortable using the letters
I
as
don't
is.
really care because it's gonna work anyway.
Okay, I'd like to use the original letters. You switch them 500 plus 25C, and now you're going to solve for C. So would you mind solving this for C for us, please?
Sure. But I don't know. So, like, do you want me to for solving for C? Do you want me like to bring 500 to the other side?
That's right. Yep. Move the 500. Move. Figure out what to do with the 25.
Okay, so when we move the 500, that's by subtracting. So it would be like negative, no, G minus 500
Good.
equals 5C.
Okay. Keep going. You're almost there.
So then after that, you would divide by 25,
Yes.
which equals G minus 500 over 25 equals C.
Yeah. So C is equal to G minus 500 divided by 25. And then this is how they wanted you to do it there. They're now giving you, and now you have to see what's awkward about this is you have to switch the variables back. So the number of guests is the cost minus 500 over, I'm sorry, yes, minus 500 over 25. So you have to switch the variables back, which is very awkward, but it is.
conflicting with this.
And then you substitute in C equals 2,500. So that's 2,500 minus 500 over 25. And that will give you the number of guests there.
I'm gonna have to do some calculators.
Yes.
$80 guests? Wow, this kid must be popular. At a birthday party, there's a max of like 10 to 20 kids.
Yeah.
Never seen 80. This kid either is popular or he's famous.
Well, I don't know how you have time to interact with that many people. That would be a lot.
Mm.
All right. Well, I know you like to take your pictures and submit here. I've got question 1 ready to go for the next assignment. So whenever you tell me, we can begin.
All right, I'm just gonna take the photo. All right, I got the photos. So I'm ready. Some more stop and thinks.
Stop and think every time. You got to stop and think.
Yeah, when you tell me to, I can stop thinking.
Yeah, I don't know. That's a great question for your teacher.
Right?
All right, so here you're working on, believe it's both direct and inverse. So we got to just cover this briefly. These notes will apply to everything. Direct variation is the equation y equals kx. Inverse variation is y equals k divided by x. You'll want to have these down for the problems that we're going to do. There are other types of variation. I'm not sure if we will see them, but for question number 1, it says m varies directly as p. So that the way to interpret that is m equals k for the variation times p. M varies directly. Think of it as m equals directly as, and then you got to decide the letter, what letter is going on the right side. The next part here is that they're giving you 2 values. They're giving you m and p or an x and a y, depending on the problem, and you have to solve for k.
Mhm.
And this is always the case. You write the equation, that's step 1, it's another recipe, and then you solve for k. What can you do to solve for k here? How do you undo this 0.3?
Now you divide.
Yes. And if you don't want to do it by hand, you go to your wonderful calculator and get that result.
My favorite thing.
Yes, yes. And you find that k equals 40. Now you're almost there, right? Step 1, write the equation. Step 2, use the values to solve for k. And then you have to use that value back in the original equation to rewrite the equation. It does say to just find the constant variation, so you are done. But typically, and we'll see this in other problems, you rewrite the equation and then you use it for some other purpose.
Mhm.
All right, that's number 1. Number 2. If Q varies inversely as W, and I don't know the number here, you have to You're gonna have to look, or I'll have to look as well. So Q varies inversely as W, K over W. Inversely is the division, and Q is that 12?
Yeah, that's a 12.
Okay, just making sure there's a little hand marker over it. So 12 and W is 4/3. So this is awful. When you got a fraction inside a fraction, it's bad. But remember, you're just trying to clear the fraction. So to clear the fraction, you multiply both sides by whatever is on the bottom, like this. So on the right-hand side, the two fractions cancel. They're gone. On the left, though, you can get that result for K, please.
You can cancel the 3, so it would be like K to 16.
Yes, K is 16. And you just have to find the constant variation. You don't have to rewrite the equation, but you will in a future problem here.
Mhm.
All right.
16, that's our answer.
Yes. All right, so the problems are getting slightly more complicated. Wasn't sure what they were going to show you here. So this time it says y varies directly as x and z. So what does that mean? It means y equals directly as k times, and then because there's two variables, it's x and z here. We're used to just having one variable. This time there's two. You can write as times if you want here. So that means to find k, you need a y, an x, and a z. Well, looky there. They give you a y, an x, and a z. They tell you y is 5, k is unknown, x is 3, and z is 4.
Mm-hmm.
So to solve for k, you can multiply these first. That's k times 12, divide by 12. K is 5 over 12.
Mm-hmm.
This is now the first equation where you actually need to rewrite it. So you're going to rewrite the equation as y equals 5 over 12, that's k, times x times z.
Mm-hmm.
Let me know when you're up to here. Hopefully the steps are clear. It's kind of going backwards. You're doing lines again. You've done a lot of lines.
Just a regular day, you know. Okay,
Yeah.
yeah, I'm also caught up.
Okay, now this is where I thought most of the problems are going. Typically, you write the equation. We did that. We got the equation, solve for k, rewrite the equation. Now they're going to give you two of the three unknowns. So this time they give you x is 2, z is 3, and they're asking you to solve for y. So they give you after you get the equation, they ask you to solve for one of the variables in the equation. So you have to take 2 times 3 is 6. Goes into 12. Looks like your final answer here is 5 over 2.
Right, I got that.
All right. Wonder what 4 is. 4 is probably all right. Here we go. All right. If Q is inversely proportional to X, so Q equals K over X. That's the first part. So you kind of got to break it up into pieces here. All right. And they give you the value of Q now. They say Q is 0.4 when X is 2.5. Will you, Ivana, use that information to solve for K for us, please?
Okay, so 0.4 equals K over 2.5. Wait, sorry. Wait, what? Find Q and X is 4. That makes no sense.
No, just focus on this middle piece of information right here.
Right.
Q is 0.4, X is 2.5. You're going to solve for K.
Mm-hmm. So I replace the Q as 0.4, and then I replace the, so then it's like K over 2.5.
Yes, and you're going to solve for K.
I assume now what I should do is first remove 2.5 from the fraction, and then
Yes.
so by that I would have to multiply it, right?
Yes. Yep.
So then I would multiply to this side to 0.4, which equals, I'm using the calculator,
Good.
which equals 1.
It does. K equals 1. Very good.
K equals 1.
All right, so now you rewrite the equation. Q equals 1 over X. Now the last part, they're going to either give you a Q, they're either going to give you Q to find X or an X to find Q. Which are they giving you? Are they giving you X or Q in that last part?
They're giving us X.
X. So they're telling you X is 4, determine the value of Q. You've got it.
So that's our answer?
That's it.
Oh my god, why did that confuse me so much?
Well, yeah, I put you on the spot there. You had to try and work it out as much as you can.
Yeah,
You did a great job though.
thank you.
All right, so let's take a look at the next one. Looks like more of the same, but you're doing great. A varies directly as B. So that's A equals, directly means K times the other letter.
Mhm.
Okay, so now they're always going to give you enough information to find K.
Mhm.
So I'd like you to, again, use those values of A and B to find K.
Okay, so 3 times 24, which we would have to, which would be 8. So K equals 8.
So let's look at that one more time. 3 equals K times 24.
Yeah, so
Okay.
that's be a decimal.
Okay. Now you're dividing by 24.
Which would so that would be a decimal, which would be,
Well, it's a fraction that does work out okay. It does work out okay. K is 3 over 24. You can use the Desmos scientific calculator to reduce the fraction, or you might see that 3 goes into both.
okay. Now it's like the second part of that thing, right?
Yeah, so now you rewrite the equation. You're like, okay, I've got A equals 1 over 8 times B. And again, they're either giving you B to find A or A to find B.
That they're giving you A to find B.
Yeah, so they're giving you A this time. How do you solve for B? How do you undo?
Well, if you multiply,
Okay.
you would multiply 1/8. So that'd be 10 over 8.
Well, think about what's here. What's here is a fraction. Okay, it is multiplying, so you can either divide by the fraction or multiply by the reciprocal of the fraction. Which sounds better, dividing by the fraction or multiplying by the reciprocal of the fraction?
Reciprocal.
So the reciprocal means multiplying both sides by 8, which means that B is 80.
Dang. All right. That's cool.
All right. So on to number 6. All right, so same thing here. Y varies inversely as x. So we have k over x. They're giving you the k value this time. That's nice. They're telling you that it's 0.32 over x. And then now they're giving you the value of 10 to put in for y. So 10 equals 0.32 divided by x. You mentioned this earlier. The way to get the variable at the bottom is to flip it, but you have to flip both sides.
Just give me like 1 second.
So now to solve for x, you multiply both sides by the 0.32. And probably had to go to your calculator for that one.
All right, let me pull up Desmos.
If you're not sure how to do it, it's got there is an algorithm for it, but I mean, we're not gonna avoid using the calculator if we can.
I'm using Desmos because I like Desmos. It's very fun.
Do you have an answer for me?
No, not yet. I put it in Desmos, but the issue is like, do I just put the 0.32 times 1 over 10?
Yes.
Oh, okay. I don't know why I wrote the whole thing. Okay, I got 0.032.
Yes. Great.
All right.
All right. Give me just a moment here. We'll move on to the next one. All right. So number 7. I'm going to just maybe have to move through these a little faster here because I know if we don't get them done, you won't be able to get the review assignment opened. All right, so it says b varies inversely as the square root of c. And they're giving you the value of b and c. Square root of 16 is 4, so k ends up equaling 4. So you go ahead and rewrite that. b equals 4 over the square root of c.
Oh my god. You're right at the speed of light. Oh my god.
Well, we want to get through these.
That's true.
And
8 equals 4. What you put right here? What you mean? So it would be b equals 4 over the square root of 16, right?
no. We got to now use the next piece of information here. b equals 4 over the square root of 9. That's this here. b equals 4 over 3.
Ah, okay, got it. Okay, that's her. So now we're ready for number 8.
Okay, so again, kind of a similar z equals k over d to the power of 3. That's the cube. Cube means power of 3. They're giving you the value of z, and they're giving you the value of d here. And then you're solving for k. So it's 3 equals k over 8. K ends up equaling 24. And then you rewrite that here in the original, z equals 24 over d cubed. And then you're solving now for z. z equals 24 over 4 to the power of 3, which is 24 over 64. And we'll reduce that down. Looks like 4 goes into both, so it's 6 over 16, and then 2 goes into both, so 3 ends up being 3/8.
So Z equals 3/8.
Yeah. All right, let's keep going here. Make sure we get through everything. All right. W varies directly with F and inversely with G. So basically writing if you want to get down to what the most difficult part is, it's writing the the equation. So now after you have the equation, you're just solving for
Okay, now what we do is, well, we multiply those.
so now to solve for K,
Are we like 7 over 0.2 the multiplying?
you end up multiplying both sides by 7 and dividing by 2. So it's 5 times 7 over 2. And that ends up being 35 divided by 2, or 17.5. And then again, you go back to the original, 17.5 times F over G. Then you're going to use these new values here to find W. So F is 4, G is 9, and you can go to a calculator, or you can do it by hand, whatever you like. I'm going to work it out here as well. So if you go back to the way it was written for with the fraction 35 over 2 times 4 over 9, the 4 and the 2 reduce. You can pre-reduce there. It ends up being 70 over 9.
And that's our answer.
Yes. All right. Now we're moving a little quickly here, but we want to get through everything so that next time we can do the review assignment. I remember that being pretty important to do.
So how convenient.
Yes. The weight of a body varies inversely as the square of its distance around the center of the sun. So we've got to convert that. The W, the weight of a body, varies inversely as the square of the distance. So distance D, W inversely is the division, like that. And just like the previous problems, they will give you W and D to find K. So they're telling you the radius of the Earth is 4,000 miles. That's D. How much would a 200-pound man weigh? Square of its distance from the center of the Earth. If the radius of the Earth is 4,000 miles, they're not giving you the weight. Okay, so I think what they're saying here is that this is the W, because your weight doesn't change based on where you are. Well, your mass doesn't change, but I don't know about your weight. So we'll just go with this and see what to make of it. So it's K over 4,000 squared. So that's quite large, but we can solve for K. K is 200 times 4,000 squared. So I'm going to definitely grab a calculator for this.
Dang. When I used the Desmos calculator for 200 times 4,000 squared,
Yes.
I got 3.2 times 10 to the power of 9.
Yes, it's quite large. So K is 3.2 times 10 to the power of 9. So your weight is 3.2 times 10 to the power of 9. Your distance now, when it says 1,000 miles above the Earth, that's 1,000 plus the 4,000. So that's 5,000 like this. And you'll want to recalculate that as well.
Okay, back to Desmos I go.
Yes.
Okay.
All right. Do you have an answer for me?
Oh, not yet. Hold on. I'm sorry. I'm writing this as fast as I can.
Sure.
Okay, that's like 640,000.
Yeah, it seems quite large. This one might be coming back. I think might have been worth looking at an example in the book, but let's go with that. I mean, this doesn't make sense. You actually, but I'm not sure. We'll see. We'll see. But this should at least get your next assignment open, and we can work on this again if we need to. But that is going to do it for us for today.